I'm with Firebase, and I've been at Google for 2 years. And this is my third time being at Next. And I remember the first time I was there, it was almost 2 years ago, just a few blocks from here. I see someone nodding over there. It was in the Warfield Theater at Market Street. Who else was there? Okay, just a few people, and actually that's how it feels. To me, that was my first big Google conference. And I was really, to be honest, intimidated with the number of people there. And now it's 2 years later, and there's over 10,000 of us here at Moscone. It's grown so much. As we say at Google, it's growing at the speed of the cloud. I remember when we launched App Engine back in 2008. It was the first tool of what would later become Google Cloud Platform. But to be honest, for us, it was just a new thing that we wanted to release out there. And now, less than 10 years later, we have over 150 APIs that you can use in the Google Cloud Platform. It's grown at a tremendous rate. That's the thing that you constantly see in technology. Not only do things keep getting better, they get better faster and faster. I'd like to take you back on a bit of a journey back in time. So we founded Google almost 20 years ago. And our mission was to organize the world's information and to make it universally accessible and useful. And that's still our mission today. But that's pretty much the only thing that has remained constant. Right? The technology that we have available to reach that mission has grown so much since 20 years ago. Think of it, it was essentially the early days of the public internet. Since we're traveling back in time, I always think back of when I got my first PC. It was just under 30 years ago. And it was sort of a hideous box that you would rather put on the far corner of your desk, or even better, under it. But it was my personal computer. It had a whopping 20 megabyte hard drive. And that made me one of the lucky ones, because hard drives were not very common 30 years ago. It had, let's see, 1 megabyte of memory. And that was a lot back then, but if you now look at your phone or your laptop, you probably have 8 gigs or maybe even 16 gigs of memory. So that's 8,000 times or 16,000 times more in less than 30 years. Moore's law has been working hard for us in the past decades. And my PC ran at 16 megahertz, and that was a lot. And it made me feel like sort of a magician. Because here was a computer on my desk that I could make do whatever I wanted. Right? I came up with a thing in my mind, and I would translate it into code, and then the PC would do exactly what I wanted. Or maybe not really exactly what I wanted, it mostly would do exactly what I told it, but still, it was pretty good. And it's a magical moment, because no generation before ours had wielded so much power over such powerful technology. It was like magic. That brings me to one of my favorite quotes, which is, "Any sufficiently advanced technology is indistinguishable from magic." It's from science fiction author Arthur C. Clarke. And it ties two of my favorite topics together. Technology, that's why I'm here on stage, and science fiction, because like many geeks, I love sci-fi. I love sci-fi for many reasons. They are often inspired stories, but also they seem to inspire technology quite often. For example, if you think back of the original Star Trek series, it was launched in the mid-60s on network TV, and the crew had to communicate with each other, and they did that using devices that they called communicators. And right, this is 50 years ago, so clearly it didn't exist back then. So the writers of the show were in a room and they had to make up a thing that would allow the crew to communicate. So they wrote in the script, they're using communicators. And then the props team, right, would look at that and it's like, okay, so we take a piece of wood and we paint it, and that's now a communicator. The technology didn't exist then. But if you fast forward 30 years, you see that actually the mobile phones became commonplace. And people across the entire world could communicate with their mobile phones. And not surprisingly, if you look at the first mobile phones, they looked somewhat like Star Trek communicators. Right? If you have ever had a Motorola StarTAC, it was clearly the same type of design. You can see how technology takes inspiration from science fiction. I always had to laugh at Picard. If he wanted a drink, he would say, computer, tea, Earl Grey, hot, and it would materialize there. He probably said it with a slightly more British accent than I can pull up here. Now, we don't have the materialization technology yet, not even us at Google, but I'm quite sure somebody somewhere is working on that. But voice recognition, I think we've done a bit better than they did in the series. Because if you now use your Google Home or your Assistant, you can talk to it and give instructions that are a lot more complex than what Picard used to do. And it will understand you perfectly. But one thing about sci-fi I always found most fascinating is when they would send a team to a planet. And they roughly had 3 types of scenarios that could happen there. The first scenario is that the planet was completely empty, and that typically meant that the planet was about to explode, or the sun in the system was about to go supernova. And they had about 40 minutes to get out of there. The second option was that the planet was inhabited by non-humanoid creatures. And those non-humanoid creatures would then not speak any language that the crew could comprehend. So the entire episode was about finding a way to communicate. And those were some of my favorite episodes because I love communication problems. But the third type of episode, and by far the most common one, was that they would beam down to the planet, they would find humanoid creatures, and those humanoid creatures would all speak perfect English. I'm not sure, but I don't fully get how that works, because I live on one planet, and not everyone speaks English, right? How do we have a galaxy that's filled with many different races, and they speak perfect English? I don't think it's realistic, but what annoyed me is they also never gave an explanation for how this worked. And language, for me, is a fascinating topic, because I often think that it's the next barrier that we're trying to break through. For example, if you have Google Translate, and you travel to a country where they speak a different language, right? You see something on the menu, you take out your phone, you type the word on the menu, and you see what you want to order. Or maybe if there's a sign, you point your camera to it, and Google Translate will show the sign in a language you understand. And that's sort of a technology we've been working at for a few decades, and it's pretty good. But about 2-3 years ago, I saw that there were releases of video conferencing software that would do live translation of speech. So there was a video release where you saw a class of school kids in the US. They were sitting in front of a PC. And on the other end of the PC, there was a class of school kids somewhere else in the world, let's say in Spain. And the kids in the US would say something in English, and the kids in Spain would hear that same sentence in Spanish. And the kids in Spain would respond, and the English kids would hear the same sentence in English. And I was like, this is magic. This is the future of communication. But, as I just said, if it's like magic, then it's probably just a very advanced technology, right? I also thought, wait, I didn't see this in Star Trek, but I saw this earlier. I read about it somewhere. Because, like any good geek, I read The Hitchhiker's Guide to the Galaxy by Douglas Adams. And he had a good explanation of why everyone could talk to each other. Because he said everyone at birth is implanted in their ear with a tiny creature called a babelfish. And that babelfish will take whatever language is coming in, and it will make it into the language that they understand. That's how everyone could communicate in the entire galaxy. And I'm like, this is babelfish, I get it. But it's been 2.5 years, and I still don't have this implanted in my ear. And now, if you saw the keynote this morning, Urs had a tiny chip, but I didn't get access to that one in time. So what I think is realistic today is that we actually turn this into an app. So I want to have an app on my phone where I have a dial that makes me select the language. And that's the language that I speak and that I understand. And then somebody else, say in Japan, also has that app, and they select their language, and that's the language that they will hear, that they will speak to me. This is sort of what they did in the school class, and what Douglas Adams predicted, but then something that we could do today, probably. And when I say today, I really mean today, because I'm checking the counter here. We have a good half hour left. We're at Cloud Next. I just said that we're going to pick the pace up a bit. So I think we can totally build this app today here on stage. Thing is, I say we, because I definitely know that I can't build this one on my own. So that's why I invited a few of my friends to help me out here on stage. Mike, Jen, let's build an app.
Thanks, Frank. Has anyone here had a boss who stands on stage and pitches for 15 minutes this magical idea and then hands you a microphone and says, go build it in the next half hour? I see a couple hands. Yeah, that's what we're doing right now.
Sorry.
So if you didn't come to this presentation, you might start thinking, this is how we need to build an app. We have our mobile applications that make RESTful calls to some application server. So that could be Java or PHP or Ruby. And then that application server handles all of the complex application logic. That's going to handle our authentication and authorization. That's going to handle all the translation, all of the storing of the files. And it's going to ship it out to the other cloud APIs, so the cloud databases and cloud storage examples that store all of that. But the counter says 46 minutes and 27 seconds. As easy as it is to spin up VMs, that would still take us too long. We would be provisioning all of our servers. Are we going to secure them in the next 45 minutes? Like, that's going to be a really, really difficult problem. We need to move really quickly to build this app to meet Frank's specs. Luckily, you all came to this talk, and you're going to learn the secret to build applications incredibly quickly. And that secret is using Firebase. With Firebase, our mobile clients talk directly to powerful managed infrastructure, like a database and an object storage solution. This means that your apps don't have to go through that middle tier and can speak directly to those different APIs. In case you were asleep during the keynote and didn't know what Firebase was, Firebase is a full application platform. It is Google's mobile platform. It allows you to develop your applications on top of Google Cloud Platform, grow your user base, and monetize and earn more money. Because this is a develop talk, we're going to focus just on a couple of those develop features that will help build our app as quickly as possible. First, a cloud storage solution that lets you upload and share exabytes, literally exabytes, of user data. Combine that with a serverless authentication system that handles complex authentication flows and session management with ease. And lastly, a real-time database that stores and synchronizes JSON data in milliseconds. Let's start first with cloud storage. Frank said that he wants to talk into his phone and upload that file to share with everyone. Cloud storage is Google's way of storing up to 5 terabyte objects. And obviously, our audio files are not going to be that large, but it's good to have that kind of scale behind the scenes. We can use the Firebase SDKs for cloud storage to take a file that we record on our device and robustly upload it to the cloud. And by robust, how many of you guys are enjoying the conference Wi-Fi? It's a little flaky, right? What about mobile networks? I commute in on a train every day, and I'm in a tunnel for 4 minutes. I want to keep using my app, and if I start uploading, I want to make sure that that file gets to the cloud. The Firebase SDKs for cloud storage handle that seamlessly. We have SDKs for Android, iOS, JavaScript, C++, and Unity, so we can meet your application needs wherever they are. And it's all serverless. You don't have to spin up any servers to proxy authentication or get signed URLs to upload from. You can upload directly to the cloud securely. And when the time comes to download and share that content, it's all coming over Google's incredibly awesome world-scale network. I promise things download really quickly. They're often edge cached, and it can instantly be transmitted out to hundreds, thousands, or hundreds of thousands of devices. But what about security? Can anyone just upload a file? We don't want, we want these two lovely folks, and we want all of you to be able to upload and download our files, but we don't want people outside or people to upload nefarious things. We need to secure that. And we can do that with Firebase authentication. With Firebase authentication, you can log in your users using any of a number of common social providers: Google, Facebook, Twitter, GitHub, your own custom email password solution, or we even have integrations to do your own custom authentication. So if you have SAML or an existing SSO provider, you can use that directly with Firebase. Again, this is completely serverless. You aren't spinning up your own OAuth flows. Have people done OAuth flows? A couple people? Have people done SAML? That's also really painful. Yeah. A bunch of people raise their hand? Yeah. We handle all of those things, and it's really, really easy. No servers, no other three-legged OAuth flows or OAuth redirects. You just use our SDKs directly from those client libraries and log your users in. The other really cool thing about Firebase authentication is under the hood, we federate all those users. So even if a user comes in via Facebook or Google, we can create a single user account and link across all of those. This is especially cool for anonymous authentication. So if you have an e-commerce site and you want users to add items to their shopping cart, you don't have to force them to log in initially. But when they check out and you prompt them to log in, you can seamlessly link that anonymous account with one of these social providers and carry all of their items over. Again, without having to prompt them to do this. It's really, really impressive. So now we're able to upload our files and download our files securely, but we need to synchronize that file information across all of our phones. And for that, we have the Firebase Real-Time Database. The Firebase Real-Time Database was Firebase's first product, and it was kind of magical, and you'll see why in a minute. The Firebase Real-Time Database is a NoSQL JSON database. It looks kind of something like this. It's just a big blob of JSON in the sky. It synchronizes across all of your client devices. In our case, we're going to be storing information about uploads, a language code, and a link to the file that's stored in cloud storage. Now, when you use traditional databases, typically they follow a request-response paradigm. So I would have to poll my database every 5 seconds or every minute and say, hey, is there a new audio file? I'm listening for things, please update me. The Firebase Real-Time Database doesn't work like that. We don't want your mobile applications polling every 5 seconds and burning through battery life. We want to tell you, as a developer, and let you say, hey, Firebase, let me know when data changes. And when any of those clients makes a change in the database, we can push that data out to all of the devices in milliseconds. It's really impressive. You'll see it here in a minute. But listening to me talk is not going to help Frank build his app. We need to switch over to code and see what it's like to actually build this app. Over on my right, so everyone's left, Frank is building an iOS app. And over on my left, your right, Jenny is building an Android app. And let's pop over to the emulators now that they're warm. And you can see the bare structure of our application. We have a sign in, sign out button up at the top. We have a language picker that lets you select what language you want to hear the recordings in. We have a big record button that lets you record and then stop recording. And a text field that shows the translated text. And what's going to happen with this application is, once they click record, the app will get an audio file on its local disk that we can upload to cloud storage. And then eventually, it will get a notification from the database that gives a little bit of translated text that will populate. So let's start filling in the guts of that. We've already added Firebase through CocoaPods and Gradle to our apps and configured it to be ready. So the first thing that we want to do is within our application, create instances of storage, authentication, and the Firebase real-time database. It's super easy to go ahead and do that. The next thing that we're going to do is start our file upload. So as I said, once you push that record button, we'll hand this function a file. And we're going to create a reference in cloud storage where we want to store that file. We'll also add some information about the file. In this case, we're going to include the content type, so the eventual APIs know how to process that. And then, using one line of code, we're going to upload this to cloud storage. It is quite literally this easy. You just say, put file, hand it the file, and we can upload it robustly. We also want to know what happens when that file is uploaded, so we're going to add listeners for failure and success. On failure, we'll pop up a little toast that says, hey, the upload failed. You should probably try something else. And on success, we'll write that metadata to the real-time database so we can synchronize it. You ready to try this out? OK, let's run the apps and try uploading something.
Hello, world. Famous first words.
Oh, what happened?
Oh, did it not work?
Oh, I don't think it worked.
Does yours work?
Oh, sad face. The upload failed. Well, you know why it failed? Because we don't want to allow anyone to upload files. Cloud storage is secured by default. We need to add Firebase authentication to authenticate Frank and Jenny and make sure that they only are allowed to upload files. So going back up to the top, we have that auth get instance. We're going to first add a little bit of business logic to check if we have a user currently logged in. And after that, we're going to cheat here a little because we have 36 minutes remaining. Authentication is really hard and it's really critical to get right. So Firebase has provided a set of libraries called Firebase UI that provide whole social auth flows. So we can import that library, set it up, and say that we want to use email as well as Google as authentication providers. And then what's going to happen with that, if the user is not logged in, we'll pop up that authentication flow and walk them through a whole UI flow to authenticate them. Otherwise, we'll start listening for translations coming in from the database. Let's try that again, guys.
Yes.
There we go. The screen just popped up. Frank is going to click on Sign in with Google, sign in with his chosen demo Google account, and here we are. Let's try uploading again.
Hello, world.
Hello, world.
There we go. So we saw the toast that said uploaded. Let's go to the Firebase console, and again, we don't want to kind of pull a cover over your eyes. We want to show you that file within our cloud storage bucket. So here you can see one file, the audio AMR from Android, and the linear 16 file from iOS. Wow, that was pretty magical, right? Let's also hop over to the database, just to make sure that we're synchronizing our metadata to the real-time database as well. And there you can go. You can see 2 files with a bunch of file metadata about Firebase. Again, so that was what, 15 lines of code, 20 lines of code, something like that? Yeah. Thank you. OK, so we have files uploading. We're doing it securely. Now we want to know anytime a new file is added, we're going to listen for a translation. And for that, we're going to use the Firebase real-time database. So we're going to create another reference to our database, and we're going to listen for translations to come in. Here, we're going to call this a child added event that says anytime a new translation comes in, notify me of that translation. And once we have that translation, we'll add yet another listener to give us the specific language code. So the way that we set it up as all the languages, and then we pull out a specific one. Once we have that language code coming in, we'll send that to the native text-to-speech APIs on Android and iOS to play that translated text, as well as populate the translated text field below. Let's rerun the app and try it out. So Frank is going to come over, and in our database, he's going to simulate translating text for us. So we have a translations reference. He's going to add English as the translation, and say something like, hello, world. And if we're doing our job here, hello, world pops up there, and on the other app, and it would speak to us as well.
Hello, world.
There you go, hello, world. So I'm done,
Hello,
right?
world.
The app does exactly what Frank wants, right? He was standing there typing in the translations. We could speak, and I don't know, he'd download it and then type them all out. I don't know, no? Okay, well, I'm done. I heard Google has some really cool machine learning stuff. Did you guys see that in the keynote yesterday? Yeah? So Jenny, do you think you can help us out here?
Not putting me on the spot or anything, are you? I kind of like the idea of Frank doing all the translations by hand in the back. No? No?
I kind of do too, honestly.
Okay, we'll actually write some software to solve this. But before we do that, can we go back to the slides, and I'll tell you a little bit about what we're going to build. Step through the coding slides. So we are going to be using some software to automate this part of it, rather than have Frank continue to code for us. And we're going to do that in the trendiest way possible, because there's probably a phrase you've heard a few times during this event so far, which is machine learning. Specifically, or well, rather generally, we could build this up from scratch. But unfortunately, like, that's something we're probably not going to be able to do in the 20 minutes we have left to write this app. It takes a lot of time to gather all the data and train all the models and get them all set up. So we're going to take a different approach. We're going to use some of those wonderful machine learning-backed APIs that are available to solve a lot of problems. And there's a huge list of them that are part of Cloud Platform that you can make use of. And we're going to use a couple specific ones to fill in the gaps that Mike left in our application. We're going to be using the Cloud Speech API to take the spoken word from all the users of our apps and convert that into a transcription, into a transcript, into text. Then once we have that text, we're going to use the Cloud Translation API to translate it into the other languages so that other users of the app can hear it in their chosen voice. So we have a solution there, right? We have our app up there running against Firebase. We're using the database for all of the structured data. We have our audio files in storage, and we have these cool cloud APIs to do like the heavy lifting. We're done, right? Well, kind of. There's one little line missing from this diagram that kind of messes it up a little bit, which is how do we wire all these things up together? So if you were to come in and solve this problem using knowledge you might have had before you came to this talk, taking a step back, there are a few different challenges that come up as our application gets this additional level of complexity. And these are it's kind of an example of larger problems that you face as your mobile apps get more complicated. So one of these challenges is secrets. So when we're building mobile apps, sometimes we have some secret information. For example, if you're writing a game, you might have the special code that helps you detect when people cheat, because people always cheat at mobile games for some reason. Or if you're using some cloud APIs like speech and translate, you might have some API keys that you wouldn't want somebody using for their own purposes. And the truth is, if you take this code and you burn it into the app and you release it, somebody's going to find a way to get that information out. And then you'll be sad, because your API key will be like out of quota, and you'll be sad. But there's a solution, which is using the cloud. We can take that information and we can put it up into the cloud and get it out of the hands of our meddling users. And we're going to take that path this time. Another challenge you face is resources. So mobile phones are amazingly powerful today. They're as powerful as supercomputers from only a few years ago. But there's one thing about them that has not scaled with that. It is batteries. So you can do all sorts of heavy lifting on that phone, but if your user's battery is dead, they're going to be sad and they will not be using your app very much. So when you have really resource-intensive stuff, you can take that load and push it up into the cloud and run it on more powerful computers, which also have the luxury of being plugged into mains electricity. Then your users will be happy, because their phones will still have batteries, and they'll continue to use your app, and everything will be successful and happy. And one more, which is kind of especially relevant to us, as I can see the little clock ticking down, is code sharing. So one really big pain for building a mobile application, especially if you want to target a whole bunch of different platforms, is having to rewrite the same functionality over and over and over again for different platforms. And this is a bummer, and there are a lot of different approaches to trying to solve this problem. But one approach to solving this problem is to put some of your resource, some of your code, some of your business logic up in the cloud and then connecting to all of your mobile devices over an API, thereby only having to write this logic once and share it across all your devices via that API. So if you were to try to solve this problem using maybe the knowledge you had before you came to this talk, using digging into your traditional bag of tricks, you might come up with a solution like this. So we have our awesome Firebase app running on those mobile devices. We'll just spin up some compute nodes, and maybe we'll write some APIs. We'll make a Django server, or we'll do some Node.js stuff. And then we'll stick the keys in there, and we'll use that to manage all that stuff, which is great. It'll be great when you get started. But then as your application gets more use and more complexity, you're going to find yourself in a more complicated place. You're going to find yourself managing all sorts of caches and firewall rules and all sorts of stuff like that. But we don't really want to deal with that today. We want something fast and easy. That's what this talk is about, right? Yeah. And at Google, we've been kind of helping you take care of your kind of app management woes for a long time. We want you to spend the time writing the code for your actual application and spending less time doing that other overhead. One way I kind of joke about it is we are code as a service hipsters. Since like 2008, when App Engine launched, you've been able to push a web app to the cloud and not have to worry about scaling up or down or how the cache is implemented, that kind of stuff. And although App Engine is still a wonderful solution to a lot of problems, it's not quite a perfect fit for what we're dealing with today. We want something a little bit different. So that's why, instead of spinning up a bunch of servers on compute or using App Engine, we're going to do something a little bit different today. We're going to use Cloud Functions. Yay. They're the perfect little bit of application glue to hold our application together. And they will allow us to solve all those problems I mentioned before. We're going to be able to take our keys and stuff them up into those functions to keep everything running nice and great and away from the prying hands of our less friendly users. It would also allow us to take the more heavy lifting our application has to do in terms of the translation and take that off of the device and put it into the cloud. And I could tell you more about how this works, but that's not what you're here for. You're here to see some code, right? So let's build it. So mine switching over to code view. Awesome. So what we have going on here is we have Frank over here on my right and your left writing some code in Cloud Functions, and we have the console on the other side so you can see stuff updating live in Firebase. So one of the first things you're going to notice is different than the last chunk of live coding we did is Cloud Functions don't need a lot of stuff to get started. Previously, we had a couple hundred lines of boilerplate code because mobile applications are just kind of like that. But all we have for Cloud Functions to get started is some variables up top, specifically that specify some authentication credentials for our cloud APIs, and a function stub. And that's all we really need to get started. So to get started, what we're going to do is we're going to add another function. And what this function is going to do is it is going to trigger whenever there is a write to the database. And the first thing it's going to do is it's going to extract some information from that, some of the metadata, including the language the user was speaking, as well as some information that's dependent on the phone platform, like the sample rate and the encoding, which, as it turns out, is different for each platform we discovered while we were writing this. So we're going to take that, we're going to hang on to it, and then we're going to send that information up to the Cloud Speech API along with a reference to the recorded file from Firebase storage. And this is actually one of my favorite parts of this implementation, is you can see that we don't actually have to download the bits and bytes of that audio recording. Because all this stuff integrates really well together, we can just send over a reference, which is nice and lightweight, and then that API is just going to slurp it down from the same place that it was stored by our mobile app. And then once we get a response back from the Cloud Speech API, we're going to take that and we're going to write it back to the database. And this actually kind of completes one whole lap on our app. We now have the point where our app can take in that recording and convert it into a transcript that we should be able to see in the database. So should we give it a spin? Let's give it a spin. Oh, and I think there it is already. Oh, that's the file uploading. So we can see the upload metadata. So now if everything is going right, the function is chugging away. And in just a moment, we will see another node appear. And it will be awesome.
Give it time.
Sometimes it takes a moment for the first one to spin up. We're going to try from the backup phone. Oh, no, there it is. We cannot blame the Wi-Fi. Or maybe we can. But there it is. Hello world in text in the database.
Can I try? Can I try?
Can you try?
Yeah.
Of course you can try.
Hello world.
I promise. We're going to say something different at some point.
Why?
Why? There are other things people want to communicate.
Oh, there it was, right there.
Woohoo! But at this point, I've only done about half of what I promised I would do when Mike handed me the baton. We've now taken the text, or we've taken the voice of the user, and we've converted it into text. But it's only in there in one language, the language that that user spoke it in, which is not quite right at all. It's just kind of like a chat device now, a communicator. We want our communicator to also have a universal translator. So we're going to solve this problem in the way you might expect by writing another function. Yay! So we're going to go ahead and we're going to add another function in our Cloud Functions. And this function is going to listen, or it's going to trigger when that transcript was written to the database. And it's going to get the transcript text itself as well as the language that the speaker was speaking. And then what it's going to do is it's going to iterate through all of the different languages that our app supports, 7 in this case. And it's going to, for each one of those, it is going to send that transcript along with the source language to the translation API. And then as the responses come back from the translation API, we're going to write those back to a different node in the database. And then finally, once the last translation has made it back, whichever translation decides to be the slacker at that time, we're going to signal to the function that we are done. And this is kind of one of the anticlimactic parts of Firebase development. Sometimes, like, you have a checklist of the 5 things you know you need to do, and then all of a sudden you finish them and you realize that, hey, wait, my application's completely done now. But I guess we should verify that for sure. Let's just give it a run.
Hello, world. We're really unoriginal.
Oh, there it goes. We see the metadata from the upload appear. Another transcript.
Hawaiians.
Ah.
Sorry about that.
Didn't expect you to be that loud.
What language is that in that it talked?
I said hello, something about Hawaiians.
Oh, okay. It didn't quite get it.
You said it in English. You selected Japanese.
Oh, this is what happens when you don't use it right. It was user error. Hawaiians, apparently, is what happens when you tell it you're speaking Japanese and you say hello world. Today we learned something. So, I guess our application is done then, right?
Hold on. Did we ever test it?
We tested the full cycle.
Yeah, so clearly if we say we speak Japanese and we say hello world in English, it doesn't really work.
Okay.
So we probably should test it, but I have a good idea for that, I think.
I clearly don't speak Japanese.
You don't? Oh yeah, this is what we learned.
Okay. Let me take this one, Jen.
Okie doke.
Can we switch back to slides for a moment? Probably this one. So when you're done writing your functions, you deploy them with a single command. You run Firebase deploy, and it uploads your code to the Google Cloud, where it runs in Google Cloud Functions. It's a single command, but it takes a bit of time, so we've prepared it this time for you. Now, to be honest, I'll admit that I came up with that I wanted these apps, but when we started this project, I was sort of skeptical, because I wasn't really sure that we could build these 2 apps in 30 minutes, and I'm watching the clock, they did. And that's actually pretty amazing, so. But if you watch very carefully, you see that we actually did slightly more than just 2 apps. There's a URL at the bottom of the screen. I'll make it a bit bigger. So we built a 3rd app, a web version of this same application. And this is audience participation time, and audio participation, actually. So if you now go on your phone or your laptop to babelfire.cloud, I love the new top-level domains, you will see an app very similar to ours. It's a read-only version of that same app, because, to be honest, I didn't want to open up an audio channel to all 300 of you. So it's a read-only version of the same app. You get a drop-down box, and you select the language, and then you will hear the last sentence we said in the language you select. So right now, that is the Japanese interpretation of Mike saying hello world. Fairly interesting. I have the same Android app installed on my phone. So I'm going to start it. And I wonder, I was scanning for familiar faces. Who here understands Dutch? So I see a few hands going up, but actually that's quite surprising, because you might not realize it, but if you open this URL on your phone, you understand Dutch. You might not have noticed, but I have a tiny bit of an accent because I'm not a native English speaker. I'm from the Netherlands and I speak Dutch. So I have the app open and I'm going to say Nederlands, Dutch. Okay. And then I'm going to say something and you will hear it in the language that you selected. You won't understand a word of what I said, but about 5 to 10 seconds later, you will. De applicatie werkt en jij verstaat Nederlands. I still hear a lot of Hawaiian, so let's see how this works. So my text is now being uploaded to cloud storage. It's being transcribed into Dutch text. Then it's being translated into the 7 languages that we have available in the app. And then it's being sent to your phone.
The application works and you understand Dutch.
Did that work? Demos are scary, but we're Firebase. We like taking a challenge. So we could still have faked this one, right? I sort of knew what I was going to say. So when you all were coming in, we asked a few people if they speak a language from the 7 that we had selected. And I think there was somebody on the first row that speaks Hindi. Is that correct? Can you come up to the stage for a moment? We'll do that right here. Okay. So we're going to do a bit of a game here. Are you game? Yeah. Cool. So I'm going to select Hindi there. Then I want you to think of a short phrase that you're going to say to the app. Now, this is taking a lot of risk because I don't understand a word Hindi. Okay, let's see. That's this option, right?
Yes.
Okay. You ready?
आवेदन काम करता है और आप डच समझ में। Okay. आज गुरुवार है और आज बहुत धूप है।
Did anyone understand that? Because I sure didn't. There's one person there. Was it friendly? We can still unplug the audio. Let's see what Translate makes of this.
You act like you understand Anne.
That is. Was that what you said? Otherwise, we're going to try again. No? Okay, let's try again. Once more. I did? No, it should be fine. That is the correct one, right? Let's try. Slightly louder, maybe.
Okay. आज गुरुवार है।
Fingers crossed for this one. It's uploading. It's being transcribed, translated to all 7 languages, one of which we've selected on the laptop there.
Today is Thursday.
That sounds a lot better. Thank you very much. I think you... Okay. What do you know? I do understand Hindi after all. Okay, let's take this home. So I started off with painting a picture of how I want apps to look. I want a universal translation app that I call Babelfire because I'm a geek. And I said I wanted 2 apps in 30 minutes. Then Mike came on stage and explained how you would probably build that app if you've never used Firebase, right? You'd write the application code, write middleware, and then interact with Google Cloud Services from that middleware. Then Mike said, no. There's a better way to do this. Because there's Firebase. And with Firebase, your application code can communicate directly with our powerful managed backend services. That means that we take care of all the scalability and security so that you can focus on building the functionality that your users love. And in this case, I'm the user and I love translations. So Mike wrote an app that would record an audio file and write it to cloud storage through the Firebase SDK. And then he wrote metadata about the audio file into the Firebase database. And then Jen came on stage and she wired up cloud functions that would be triggered from the metadata and would take the audio file and send it to the Cloud Speech API and return a transcript of the text that was spoken. Then we write it back into the database. We have another cloud function that gets triggered that sends the text to Cloud Translate and translates it onto 7 languages that we have available in our app. Right? We get the translations back and we wrote them into the database, where Mike picked them up in the app and spoke them on the device with the text-to-speech. This all in 30 minutes. Sure, we did some prep work, but to be honest, I doubt there's a lot of technologies out there that allow you to do that much in this little time. And this is Google. So this has all been built to Google scale. That means that if your app takes off, and you suddenly are indeed implanted into every human in the world, it will scale with you. We also have a lot more APIs. We just use 2 of cloud APIs. There's 150 or more of those. And this is one of the things that gets us excited about cloud functions in combination with Firebase, because we just picked 2 APIs and made a very cool story out of it. You can pick other APIs and build your own story out of it. In fact, if you like doing that, then I highly recommend that you stay in this room after our session, because we have Brandon and Thomas coming up here. They have an entire box full of these snippets of code, and they're just going to glue them together and build beautiful stories out of it. I highly recommend that you stay around for that. I definitely will. Okay, and with that, I think we're ready to wrap up here. So I really want to thank you for being here and building this application with us. If you have any questions about Firebase, come meet us in the experts area, which I think is downstairs, if I remember correctly. Or, to be honest, find anyone with a bright yellow shirt with Firebase on it. In fact, I see the 2 founders of the company sitting there. They will love to answer your questions, because there's, to be honest, nothing more that Firebasers love more than interacting with developers that use our technology. Okay. With that, I want to thank you, and I look forward to actually chatting to as many of you as possible during the rest of Next, because I can't wait to see what you build next. Thanks.
We have time for questions.
Mike says we have time for questions. Anyone?
Come up to the microphones if you have questions.
We scared him.
Yeah. Or come up and talk to us. We're okay with either.